So students, we shall start the integration of here we have the integration in the form of a function ax plus b dx. So now let's start. When you integrate a function which is a in the form of like ax plus b and it has power n. So when you know the derivative, 1 by derivative of this function is always here. So 1 by derivative of this function is nothing but a into power will increase by 1 and that exponent comes in denominator. Plus c is the exponent form. Plus c is the arbitrary constant. Again here in this question, in this form 1 by ax plus b. So you know that 1 by derivative of this function, 1 by derivative of this function is derivative of this function ax plus b is a into 1 by x has a derivative which is nothing but 1 by x has a integration is nothing but log ax plus b under the mode. Plus c is the arbitrary constant. Similarly, if ax plus b into derivative of x means we are going to integrate this function with respect to x, so this function will remain as it is. 1 by derivative of this function which is a, again here also 1 by derivative of this function is 1 by b. Now a is here not the e, so that is going to be where we need to take the log here. So a b x plus c by, when you take the log, so you get log a. By substitution method you can always solve this. So you when you apply the substitution method, so you can solve this. So it's better to remember the formula here. This is for the purpose of it's not cramming, it's just like you need to remember this. Once you analyze each and every single formula, then only you can remember this formula. So now next, in the fifth case, here we have what? Sine has a integration minus cos as remain as it is into 1 by x. Here whole x is ax plus b, so it has a derivative a. Now in the next case, cos ax plus b, again ax plus b has a derivative what you all know, which is a. So 1 by a you always write 1 by derivative into cos x has a derivative integration which is sine. Similarly here also, so in this case you can easily identify what will be your answer. So these are the trigonometric functions which you need to integrate by yourself, and it is very easy once you know the differentiation of a respective function, so you can easily calculate the integration of that particular function. So now we move on to the integration by substitution method. So whenever in the integrand, whenever you see the derivative, you have various questions found out on your NCERT. When the derivative is given inside the integrand and the function which you derivate is also given, so you always put that function which you derivate and find out the derivative as t. So here we have phi x is the function which we derivate and we find out phi dash x. So what we do, we put phi x as t. Okay, so when you put it as t, so phi dash x into dx will become dt. Okay, so 1 by t is nothing but natural log t plus c. Now you can put the substitute the value of t here, which is phi x, which you assume. So this is substitution methods. So this method is a very useful method when there is uh, a function which has a derivative, that function, and the derivative of that function is always given in the integrand. So you can easily find out the use this method and find out your integration. So now next move on to the next method of integration. So here when I will you can derivate this kind of derivative and this kind of derivative easily by applying substitution method. So I'm interested in the integration of the form of sine to the power m x and sine to the power cos to the power, means sine has some exponent and cos has some exponent, and we want to integrate. So how can we integrate those functions which has higher power of sine and cos? So as we all know and have learned in the class 11th of this formula, sine square x is equal to 1 minus cos 2x by 2, cos square x 1 plus cos 2x by 2, sine 3x, very famous formula, sine 3x 3 sine x minus 4 sine cube x, cos 3x 4 cos cube x minus 3 cos x. So these are the formula which we learned in our previous classes. So we just have to recall those formulas while solving the integral for higher powers of sine and cos. And I must tell you this, such questions have often come mainly in CBSE exams as far as my experience is concerned. So kindly make these formulas as important in your list. So what you have to do, you have to convert these formulas in this form and separately integrate this, and you will find your integration very easy. So let's move on to the another integral form, which is of this form. Ax plus b means an algebraic expression in the numerator and the quadratic expression in the denominator in the square root. So how can you solve that? So I would suggest you to simply remember the result in such cases. Whenever you find out such problem, algebraic expression in the numerator, and in the denominator you find out any quadratic expression under square root, so you can simply make the twice of this and plus c is your integration answer. Whenever you solve, find out such problems in objective questions, so you can directly put out your answer. But for solving purposes, how can you solve this? So this is not tough, but you can solve this in your here, like what they did here, they multiplied the numerator by 2a and denominator by 2a here. So and take the a common, so they are left with what, this, and they are making the perfect square in the numerator and taking some things common out and making some substitution and finding their answer. So what I am saying is, you can take in case of question number 8, the denominator, always remember your answer would be twice of square root of x square plus bx plus c. So I'm not bothering to solve this question, but you can always solve this question by taking perfect square and square root. Now in the next section, integration by part, this is very important, integration by parts. When two functions u and v are given such that they are in multiplication and you have to find out their derivative. So you all know, how can you find out the derivative? When two functions are in multiplication, when you find out their derivative, so it's very simple, u v dash plus u dash v, you can find out where dashes represent the derivative. Now here in this case, how can you do that? So when you take the integration for differentiation, it is very simple. When you take the integration of two functions in multiplication, so what you do, So you use islet. What do you use? Islet. So what islet says, first function always choose I stands. I'm going to tell you what I stands. I stands means inverse, L stands means logarithmic function, A stands for algebraic like ax plus b, such expressions, and T stands for trigonometric functions, and E is obviously the exponential functions. So what I am interested here in discussion is how can we use this islet expression. So we always use these islet as first function. Okay, and how can we integrate? So first function, okay, like here first function is you assume u here first function, and integrate. Choice of first function will always decide by this, whichever comes first you have to choose it as first function. Okay, so first function into integral of second function minus integral whole derivative of first function into integration of second function. Okay, remember this is the islet condition in which you use first function. Islet is basically is a process by which you can use the first function whenever you multiply in integration. Hope you understood my today's topic of discussion about integration. Rest of the portions for integration will discussed in the next video. Thank you.